So today we are going to see the arcs of circle method of constructing an ellipse. Now as you already know the basic terms of ellipse, where this A and B is equal to your major axis, and in arcs of circle method basically these 2 points F1 and F2, that is your focal points, and let's say P is the point that is a moving point. So the summation of the distance, that is F1 to P plus F2 to P, that is equal to major axis of the ellipse. So by keeping this equation in mind, this method of arcs of circle is basically where you will get number of points of arcs at different combinations of major axis. You will find number of points on the periphery, and by joining that points you will get an ellipse. So to construct an ellipse with the help of arcs of circle, first of all what we need is the distance of major axis. So let's say for an example, the major axis of this ellipse is 150, and the distance between focus 1 and focus 2, that is also given. Let's say it is 80 mm. So first of all we will draw a horizontal line on which we will find 2 points, that is F1 and F2 at the distance of 80 mm. Okay, and from the center we will also plot major axis, that is 70 mm on each side. So here you will get point A and point B. Now as we discussed, in arcs of circle the moving point P is F1P plus F2P is equal to 150, that is your major axis. So what we will do is we will take different combinations of F1P and F2P for which the sum amount will be 150. For example, 75 plus 75, that will also be equal to 150. 80 plus 70, okay, 90 plus 60, 150. So there are different combinations for which the sum amount will be is equal to your major axis, that is 150 mm. So now let's say for this combination, if you want to plot the points, so here as you can see F1P is equal to 75 mm. So from F1 we will take the distance of 75 mm and we will make an arc on both the sides. Now F2P distance is also 75 mm. So again we will take the distance of 75 mm, we will keep F2 as a center and draw an arc on both the sides. So for one combination we have got 2 points on either side. Now similarly we will repeat the pattern for all these combinations. Let's say for example 80 and 70, here F1P is your 80 mm. So from F1 we will take the distance of 80 mm and we will draw arc on both the sides. And from F2 the distance is 70 mm. So from F2 we will take the distance of 70 mm and we will draw the arcs on both the sides. Similarly for this combination 90 and 60 also repeating the same method, we will get 2 more arcs over this side. Okay. Now if we reverse this method, for example let's say I am reversing the digits, that is 50, 100, 60 and 90, okay, 70 and 80, and similarly for 75 we already have one combination. So by doing this we will get points on this side of the arcs. So here also we will get the arcs for these combinations. Okay. And now if we will join all these points, you will get the ellipse. Okay. So if you consider 150 mm, we will get the major axis as well at this intersection points. So as you can see, by plotting this, we will get an ellipse in which the sum of this distance, that is f1t plus f2p, will be is equal to your major axis. Okay. Now, if we want to plot tangent and normal at any point, for example, let's say I have taken one random point, and if I want to make tangent and normal at this point, so what we will do is, first of all, we will join this point to the two focus points. So I will join this point to F2 and I will join this point to F1. Okay. Now we are just talking about this one point. Okay. So by joining this point to focus 1 and focus 2, here we have got an angle. Okay. Now what we have to do is, we have to bisect this angle. By bisecting this angle, we will get the normal to this curve. So as we know how to bisect an angle, I will take a random distance and make an arc on these two lines. Now keeping the same distance, I will take this as a center. Let's say this point P and Q. I will take point P as a center and make an arc. And with the same distance, I will take point Q as a center and make an arc. And then we will get a new intersection point. Now if we join this point and the point on which we want to find the tangent and normal, if we combine this line, this will be your normal. Okay, and tangent will be perpendicular to this line. So now if I draw a line perpendicular to this point, this will be your tangent. Okay. So by this method, if we know the distance of f1 and f2, that is the distance between two focus points, and if we know the distance of major axis, then we can plot an ellipse with the help of arcs of circle method.